Happy Chemisters, this is Mrs. Vanderlei bringing part 2 from chapter 2.9. So far what have we done? We have learned how to find how many moles and atoms. We've also learned to find moles and grams. Periodic table, remember? So this section is how do I go from atoms to grams or grams to atoms? And I call this a two-stepper. Think of a mole as a bridge. How do you go from Ohio to Kentucky? You have to cross a bridge, don't you? You have to go to the bridge and then off the bridge. And that's the idea of what the mole does. So it helps you convert from, in this case, atoms to moles, moles to grams, or from grams to moles, moles to atoms. You're going to find out that there are many other things moles can go to, but for right now, that's where we're going to go, okay? So it says, how many copper atoms are in a copper penny with a mass of 3.10 grams? Now, do you see the word mole in the problem? I don't. If you do not see the word mole, you know it's at least a two-step, okay? Just FYI. So I did this knowing it is at least a two-stepper. So everyone, what has to go on the bottom? If I start off with grams right here, what has to go on the bottom is grams. Why is it doing that? Now, where did that grams come from, everyone? Periodic table? That's right. That's where the 63.55 comes from. And what's the only thing that can go to? The mole. So I'm going to put mole on top. Now, do I want moles? Look. Do I want moles? No, I want atoms. So I don't want moles. So guess what? Moles has to go back on the bottom again. And what goes on top? Oops, not that. Not that. Come here. There we go. Found it. 6.02 times 10 to the 23rd atoms. So notice what happens here. We can cancel out, here we go, we can cancel out grams, we can cancel out moles, and we are left with atoms. And that is what we want. So now it's time to get out our calculators. So what is 3.10 divided by what divided? It's in the denominator. Divided by 63.55. Now this is on top, so I'm going to times 6.02. Hey, what button comes next? EE 23. And when you get done, what do you get? Well, I got this, 2.94 times 10 to the 22nd atoms. Why don't you try number 25 on your own? Pause this, and when you're done, come back. I'll be here. All right, so how'd you do? Was this a two-stepper? Actually, no, it is not. It's a three-stepper. Why is it a three-stepper? Because we didn't have grams to start with. Periodic table, we have carats. So I have to do something with carats. Well, if carats are here, what goes on the bottom? Carats. What goes on top? Oh, grams. Periodic table, that's right. I'm going to put grams on the bottom so they cancel out. Now what? I have moles. Now what? I don't want moles, I want atoms, so moles goes on the bottom and atoms goes on the top. So when I get out my calculator, it's 1.3 times 0.2 divided by 12.01 times 6.2 EE23. And what do you get? This is what I get. Hey, look, isn't that funny? It's the same number as the 1.3 carats. Isn't that funny? Haha. Why do you think that is? All right, well, if you do the math, you'll see that things start canceling out. So that kind of works out pretty nice. What is 0.2 times 6 is 1.2, and that's what you're dividing by is 12, so it's off by a factor of 10. That works out pretty nicely, doesn't it? Okay, what about the next one? Will you please go ahead and do the next problem number 26 for me and see how you do. So pause this, do it, and come back. All right, how'd you do? Well, is it a two-stepper? I think it is. All right, so I just have atoms and I want mass. It's kind of like the opposite of here. My final answer is going to be grams, isn't it? Periodic table. So what do I put on the bottom? Here's atoms. What goes down here? Has to be atoms. What's the only number that atoms goes to? 6.02 times 10 to the 23rd. And what's the only thing that can go to is the mole. It's the mole bridge, isn't it? So now what? What goes on the bottom is a mole. and then 182.84. Where'd that come from? Periodic table, Mrs. Vanderley? You're right. And so now what? I'm going to go 2.25 EE22 divided by 6.02 EE23 times 182.84, and that is 6.83 with 3 sig figs. Number 27. This is a little bit different. We want to go from atoms to centimeters radius. Well, what do you think of a sphere? Do you think you can get a volume in there? So I'm going to go from atoms to volume. We didn't learn that. Can a mole go to volume? No, mole goes to grams. Wait a minute, grams? Periodic table, that's right. But what else? What does grams mass and volume? That's density, isn't it? So I wrote, look in chapter 1 notes for the density of aluminum. I'll give you this one, but for the next couple, you need to go back and look at your notes. There's your density. So I need to find, oops, not that. I need to find, there we go, whoops, mass, then I can use density, then I can find volume, then I can find radius. So let's go ahead. This is like a multiple stepper, isn't it? So I'm going to find grams first. Periodic table, that's right. But first I need to go get rid of my atoms to moles, right? What goes on the bottom now? Moles. And where'd that come from? Periodic table. And so now what? 8.55 EE22 divided by 6.02 EE23 times 26.98 equals this. Now what? How does that help me? All right. I got grams, periodic table. Okay, I've already used that. Thank you. Quit saying that. I need volume. So, all right, here we go. Cubic centimeters is equal to 3.83 grams. Don't use periodic table. I already did it over here. I don't need moles. I need cubic centimeters. So I'm going to put grams on the bottom. That is my density, isn't it? I split up. Here's my density. Put grams on the bottom, cubic centimeters on top. So what is 3.83 divided by 2.71? Do it. And this is what you get. But I'm not done yet. All right, so now we found the volume is 1.41 cubic centimeters. And now we need to know our formula. Hopefully you remember this. Volume of a sphere is 4/3 pi r cubed. So I'm going to plug in, oops, not that. Plug in our value, 1.41 is equal to 4/3 pi r cubed. I found that r cubed is equal, come here, is equal to 0.337. So I took the cube root of that and I got this as my answer. What I'd like you guys to do now is to do problem 28 and 29 on your own. Look through the examples I gave you and you should be fine. We'll do those first thing next time. See you later. Don't wait to be great.